In our next presentation of Session 7, we're going to discuss container collections vector, hash table, and enumeration, as well as generic forms from Java 5. The legacy class containers vector, hash table, and enumeration. So let's discuss legacy classes. So early versions of Java did not include a collections framework. It only was defined as an interface that provided methods for storing objects. When the collections frameworks were added with Java 2 or 1.2, the original classes were re-engineered to support the collection interface. These classes are also known as legacy classes. All legacy classes and interfaces were redesigned by Java Development Kit 5 to support generics. In general, the legacy classes are still supported because there is still code that uses them. There are still applications today that still use these so-called legacy classes. The enumeration interface. So the enumeration interface defines a method to enumerate. Identify one at a time through a collection of objects. So point to a collection of objects one at a time. This interface is superseded or replaced by the iterator interface. However, some legacy classes such as vector and properties define several methods in which enumeration is still used. It specifies the following two methods. So here we are, has more elements, returns a Boolean, true if there are still more elements, and next element. And next element returns the next object in the enumeration. So each call to next element method obtains the next object in the enumeration and then throws an exception when the enumeration is complete. The vector class. So a vector is very, very similar to the array list. They're essentially dynamic arrays. There are two differences between vector and the array list. First, the vector is synchronized while the array list is not. The second is that it contains many legacy methods that are not part of the collections framework. With the release of the Java Development Kit 5, vector also implements iterable. This means that the vector is fully compatible with collections, and vector can have its contents iterated by the for loop or by different ways to manipulate the iterator. The vector class is overloaded and contains the following constructors. So if we don't pass anything, this creates a default vector which is initialized to size 10. If we pass in an integer, that creates a vector whose initial capacity is specified by the size, so whatever size we pass in. An integer and a second integer, this creates a vector whose initial capacity is specified by size and whose increment is specified by the second integer. This increment specifies the number of elements to allocate each time when a vector is resized for the addition of objects. And then passing in a collection, this creates a vector that contains the elements of a collection. So the vector class defines several legacy methods. So let's take a look at the vector methods. So void add element, and then passing in an element adds an element to the vector. Element at index. So this is a way of querying the vector to query the value at a specific index, and it returns the value at that index. Enumeration elements returns an enumeration of an element in a vector. First element will return the first element in the vector. Last element will return the last element in the vector, and remove elements doesn't return anything, but it removes all of the elements of the vector. A hash table, like the name sounds, is actually a two-dimensional data structure. It uses a key value pair, so the values are actually kept in the cells of the table, but all you need is the key to the cell to return the value in that cell. So it only one value has to be passed to return the value in that cell. However, neither keys nor values can be null. So again, it is a key value pair. There is a difference between a hash map and a hash table. The hash table is synchronized while the hash map is not. And the hash table has the following constructors. So we have a hash table with no parameters, and this creates a default size of 11. So it creates a hash table with a default size of 11. If we pass in an integer, it creates a hash table that is initialized to the size that's passed in, the integer that's passed in. A hash table with an integer and a float creates a hash table that is initialized with the integer specified by the integer and a fill ratio specified by the float. And the hash table here with this type of parameters passed in creates a hash table that is initialized with the elements of m. The capacity of the hash table is set to twice the number of the elements of m, and the default load factor of 0.75 is used. A hash table or a hash map is a very popular data structure for shopping carts in e-commerce websites. And a little bit about the differences between the hash map and the hash table. The hash table is synchronized, the hash map is not synchronized. Because of thread safe, hash table is slower than the hash map, and the hash map works faster. Neither keys nor values can be null in the hash table, whereas the hash map, both keys and values can be null, so it gives you more flexibility. And with the hash table, order of tables remain constant over time. With the hash map, does not guarantee the order of the map will remain constant over time. And take a look at this link. This link might be a little dated, but if you want to take a look at the documents on the Oracle website for a hands-on guide for how to work with legacy codes in Java, simply go to the Oracle website or just even search and you'll see a tutorial on generic legacies. Stay tuned for our next video where we will continue our discussions on Java collections.